How did China get high-speed rail technology? Data shows that by the end of 2021, China's high-speed rail operating mileage has exceeded 40,000 kilometers, ranking first in the world, accounting for 60% of the world's total high-speed rail mileage. In addition, China has the most advanced commercial high-speed rail technology in the world, the Fuxing EMU. China has become the country with the most complete high-speed railway system technology, the strongest integration capability, the longest operating mileage, and the highest operating speed in the world. China has not only realized the localization of high-speed rail, but also realized the export of high-speed rail. The Jakarta-Bandung High-Speed Railway is a high-speed railway connecting Jakarta, the capital of Indonesia, and Bandung, the fourth largest city, and the first high-speed railway in Southeast Asia. It is also the first time that China's high-speed rail has implemented a whole system, all elements, and a whole industry chain overseas. China's high-speed rail has grown from nothing and has become a leader of the world's railways from a chaser. How did China achieve this? How did China get high-speed rail technology? On October 22, 1978, Deng Xiaoping, the then Chinese Vice Premier of the State Council, arrived in Tokyo for an 8-day visit to Japan. According to the itinerary, Deng Xiaoping was going from Tokyo, Japan to Kyoto. The distance from Tokyo to Kyoto is about 370 kilometers. Let's take a plane, it's too close, it's time to land right after takeoff. Let's take a car, the travel time for this distance is about 4 or 5 hours, which will make the old man uncomfortable. Therefore, the Japanese side strongly recommended the Chinese personnel to take the Shinkansen. Of course, the deeper reason is that Japan wants to show off in front of Deng Xiaoping. Therefore, on the basis of full communication, Deng Xiaoping finally chose to take the Japanese Shinkansen to Kyoto. In 1978, the fastest design speed of Chinese trains was 120 kilometers per hour. When Deng Xiaoping got on the 200 kilometers per hour, 181 Shinkansen train, he was greatly shocked. The staff asked him what he thought of taking the Shinkansen. Deng Xiaoping replied, "It just feels fast, and it has the meaning of urging people to run, so it is more suitable for us to take this car. We are now suitable for such a car."
怎么样？这个乘新干线以后有什么？
就感觉到快。
速いと思います。
就催人跑的意思。
追いかけられて走ってるような気がします。
所以我们现在更合适了。我们现在正合适做这样子。
Deng Xiaoping's visit to Japan unexpectedly became a big popularization of the high-speed rail concept in China. Japan's high-speed rail is very advanced. The Chinese do not admit defeat. Especially in 1978, the spring breeze of reform and opening up had blown all over China. Aspiring Chinese people were preparing to roll up their sleeves and work hard, and the railway people were no exception. Shortly after Deng Xiaoping's visit to China, Chinese railway personnel decided to conduct a high-speed test, and successively produced the Central Plains Star, power-distributed EMU, and the China Star, power-concentrated EMU. Before the introduction of foreign high-speed rail technology, there were two factions in China's domestic railway field. One group advocated the construction of maglev high-speed rail to achieve overtaking on curves. The other group advocated the study of wheel rail high-speed trains to build their own high-speed rail. The Ministry of Railways organized various main engine factories and universities to develop a variety of wheel rail EMUs, among which China Star is the research result of the wheel rail school. The number of the China Star EMU is CJJ2, which is a centralized power EMU. China has independent intellectual property rights. The design speed of China Star reached 270 kilometers per hour, and on November 27, 2003, It set a record of the first speed of 321.5 kilometers per hour in China's railways. It was not until 2008 that the record was broken by CRH2C. November 28, 2002, may be an important turning point in the fate of China Star. Fu Zhihuan, the minister of the Ministry of Railways that day, led a group of leading experts to get on the train. The plan was to get on the train at 9 o'clock that day. At that time, for the sake of safety, the vehicle was specially arranged for a trial run first, and it ran at a speed of 285 kilometers per hour. When the vehicle returned to the base, an axle temperature fault was reported. The inspection found that smoke was emitted from the bearing seat of an axle of a power car produced by Datung locomotive. The bearing temperature reached 109 degrees Celsius, and the train could no longer continue to run. The leaders who waited for a long time finally gave up boarding the train. Although the domestic emus at that time had completely independent property rights, some major core components such as high-speed pantographs, vacuum circuit breakers, GTO devices, high-speed bearings and screw-air compressors were imported from abroad, and there were no domestic supporting components at that time. The main reasons for the final elimination are the failure rate, high cost, and immature technology, which cannot meet the urgent domestic demand for high-speed railways. After the China Star, the development route of China's high-speed railway has changed, leading the introduction, absorption and re-innovation. China Star completely lost the EMU bidding qualification in 2004. China Star ultimately failed to mass production, mainly because the progress was too slow, and China's railway planning cannot wait. The rapid economic development in those 10 years, the increasingly abundant travel needs of the people, and the development plan of railways as the main artery of the economy, urgently needed high-speed trains. At this time, the average speed of Chinese trains was less than 80 kilometers, while Japan, Germany, and France successively mastered the high-speed rail technology with a speed of 250 kilometers per hour and realized commercial use. In desperation, the Chinese Ministry of Railways returned to the old way of introducing foreign automobile industry and producing joint ventures. In 2004, the Ministry of Railways launched the 6th speed-up, 200-kilometer EMU train bidding for China Railway, with a total of 140 EMUs. The tender attracted German Siemens, France Alstom, Japan Kawasaki Heavy Industries, Canada Bombardier, and other companies. China has obtained advanced high-speed rail technology through Market for Technology.